Welcome back. So let us go through the question first. A ball is dropped from height of 90 meters on a floor. At each collision with the floor, the ball loses one-tenth of its speed. Plot the speed time graph of its motion between t is equal to 0 to t is equal to 12 seconds. So what is the context here? Suppose this is the floor, this is the ball, the height is said to be 90 meter. So the ball will be coming down from here, and at any at a particular instant it will be, the position of the ball would be this, then it will be at the position this, and eventually it will hit the ground, and then it will move upwards. But now the ball will not reach to its initial position, which is here. It can be it can reach to a position which is here, 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 or even here, but it will not definitely reach to this position. Why? Because it loses its speed. And what amount of speed is that? It loses one-tenth of its speed. So if the initial velocity is u, after losing one-tenth of its velocity, its second velocity would be what? 9/10 of its initial velocity, which is u. So that is the context here. Now we need to calculate the speed and time at different instances, and then we need to plot the graph, right? Now let us go through the solution. So at time t the velocity is 0, initial velocity u is 0, acceleration is equal to the value of g, which is 10 meter per second square. uh, it is actually 9.8 meter per second square, but for the sake of simplicity we assume it to be 10 meter per second square, and the height is 90 meter, which is given. So the distance it travels is the height itself, which is 90 meter per second, and u here is 0, t we do not know, and a we know, which is 10. And the sign of a would be positive, because it is having a downward motion, right? So from this formula we can calculate the value of t, and we find it to be 4.242 seconds. Then we need to calculate the value of v by simply putting the value of t and g, and as u is 0, we already know the value of v is coming to be 30 root 2 meter per second. Now the above is the speed with which the ball will collide with the ground, and we know that it will be losing its speed, as I have already explained. So after colliding, the upward velocity becomes 9/10 of its initial speed, which is 30 root 2, and which will be eventually 27 root 2 meter per second. And the acceleration, now it is becoming negative 10 meter per second square, as the direction of the motion is upwards. Okay, so the v is this, acceleration a is this, so we can again find out the value of t by putting out all these values. So we know that the value of v is negative 27 root 2, and the value of u, which is the previous value, which is this, is 27 root 2 meter per second square. The same, the value is same, just the signs are different. And after putting the value of putting in the value of a, we get t to be 7.635 second. So after the first collision, the speed will become 0 in time, 2 root 2, 2.7 root 2 seconds. So the total time would be what? The previous timing, which was 4.242, and this timing, which is 7.635, and the total time would be 11.87 seconds. So again, you can find out the value of the next speed, and this speed will also be losing value. So it is having a value of 9/10 of its previous speed, which is 27 root 2, and it is coming out to be this much. And after that, you need to plot the values that you have already calculated in this particular graph. So you have the speeds at different instances of time. You just need to plot the points and join them. That's it. Hope it's clear. See you in the next one.